In this problem, we're told tall buildings are designed to sway in the wind. In a 100 km/h wind, for example, the top of a 110-story Sears Tower oscillates horizontally with an amplitude of 15 centimeters. The building oscillates as its natural frequency, which has a period of 7 seconds. Assuming simple harmonic motion, find the maximum horizontal velocity and acceleration experienced by a Sears employee as she sits working at her desk located on the top floor. Compare the maximum acceleration as a percentage with the acceleration due to gravity. So what we want to do here is just write down what we're given first. So we're given two different things, right? We're given that the amplitude, right, A, I'm going to call it, is equal to 15 centimeters. We're also given that the period, we denote that by uppercase T, is equal to 7 seconds, okay? So we're given these variables, and what are we trying to find? We're trying to solve for V max in the horizontal direction and A max. So you can just call them V max and A max. So this is what we're trying to solve for. And then we'll do the third part after we find these. So there's formulas for V max and A max that you should know. Right, so Vmax, the formula for it is 2 pi times amplitude all over the time, right, so the period. And then Amax, right, so the maximum acceleration is 4 pi squared times the amplitude over t squared. So this is the formula you can use to solve for both of these, right? And so notice what we're given. We're given A and we're given t. But when we solve for this, we need to make sure A is in meters and not in centimeters. Because we want it to be in meters per second, not centimeters per second. So 15 centimeters is 0.15 meters. All we do is divide it by 100. And so all we have to do now is just plug it in, right? So 2 pi multiplied by A, which is 0.15, right? This is meters, all over T, which is 7, and then seconds, right? So if you go ahead and do this, plug in your calculator, you want to do 2 times pi times 0.15, then divide that whole thing by 7. And so when you do this, you're going to get 0.1346, and so on, right? And you can round however you want. I'm just going to round to the tens place, right? Or hundreds place. And so it's going to be 0.13 meters per second, right? So 0.13 meters per second, you can round however you want. But yeah, so that's the first part. Now let's do this part. So it's just going to be 4 times pi squared times A, which is again 0.15, right? All over t squared. So t is just 7. We know 7 squared is 49, but I'll just write 7 squared. Right, so keep in mind it's 7 seconds squared, right? So if you go ahead and do this now, so do 4 times pi squared, multiply that by 0.15, and then divide by 7 squared, which is essentially just 49. You're going to get 0.1208522 9 and so on. I'm just going to round to 0.12. So keep in mind the units, meters, and then this is second squared, right? Because we're squaring it. So meters per second squared, right? So these are going to be your answers to the first two parts, right? Okay, so this is A, or right? I guess there's no A and B, but this was the first one. This is your Vmax, this is your Amax. And then the last part says, compare the maximum acceleration as a percentage with its acceleration due to gravity. So essentially what they want us to do is find a percentage between the maximum acceleration and the acceleration of gravity. Meaning all we have to do is take Amax, right? And then divide it by gravity, right? And we know what gravity is, just 9.8. You can do 9.81 or however you want to do it. Generally, we just use 9.8 though. So just use the gravity estimation your teacher wants you to use. But yeah, so Amax over 9.8. We know Amax is 0.12, and I'm just going to round, so 0.12085. I'm just using the more exact value here, all over 9.8. So just plug this in, right? So 0.12085 divided by 9.8. Right? And then you're going to want to multiply this by 100 because we're taking the percentage, right? So multiply by 100, and that's going to give you the percentage. And when you do this, you should get about 1.233 and so on. I'm just going to round it to 1.23. So 1.23%, that's going to be, right, the maximum acceleration as a percentage to the acceleration due to gravity. So this would be your answer to the third part, essentially. But yeah, so these are going to be your answers, Vmax, Amax, and then Amax compared to gravity. So these are your answers, and hopefully you found this useful.